Welcome to tonight's space sleep story. A peaceful exploration of a place that doesn't exist yet, but could. We're visiting a lunar base imagined by engineers and dreamers, designed in blueprints and scientific papers. Tonight, no dramatic countdowns, no roaring rockets, just a quiet tour through theoretical habitats near the moon's south pole, where future humans might live, work, and gaze at Earth hanging in the black sky. Settle into comfort. Let's explore tomorrow together. You find yourself standing inside an airlock, already here, already arrived. Outside, the lunar surface stretches toward Shackleton Crater. Coordinates 89.9 degrees south. This crater, 21 kilometers in diameter and 4.2 kilometers deep, holds something precious in its permanently shadowed regions. Water ice. 600 million metric tons of it, waiting beneath the surface. A resource that could sustain human life for generations. The habitat dome curves gently overhead, partially buried in lunar regolith for protection. This isn't science fiction, but extrapolation from real ARTEMIS program plans. On December 11th, 2017, Presidential Space Policy Directive 1 directed NASA to return humans to the moon for sustainable exploration, not just to visit this time, to stay. The base you're exploring exists in detailed architectural studies, waiting for the day construction begins. Consider the environment outside these protective walls. Lunar surface gravity measures 1.625 meters per second squared, just 16.6% of Earth's pull. Walking here would feel like gentle bounding, each step lifting you higher, longer. The low gravity reduces structural stress on habitats, allowing designs impossible on Earth. Engineers embrace this alien physics, building upward with confidence, creating spaces that feel both grounded and floating. Calm, slow. The temperature extremes are staggering. In direct sunlight at lunar noon, the surface reaches 127 degrees Celsius. During lunar night, it plunges to negative 173 degrees, a 300-degree swing. But inside this habitat, advanced thermal management systems maintain perfect comfort. Imagine the engineering required, the layers of insulation and active cooling, protecting you from conditions that would instantly be lethal outside. A lunar day lasts 29.5 Earth days. 14.75 days of continuous sunlight, followed by 14.75 days of darkness. Habitat designers plan artificial lighting cycles to maintain your circadian rhythms during the long night. Soft LED panels would brighten gradually in the morning, dim peacefully in the evening. Your body's internal clock preserved, even hundreds of thousands of kilometers from the sun's familiar 24-hour rhythm. Look down at the floor beneath your feet. Beneath this habitat lies lunar regolith, varying from a few centimeters to several meters in depth. It's composed of fine dust particles, 10 to 100 micrometers across, created by billions of years of micrometeorite impacts. Approximately 1,000 metric tons of micrometeorite material strikes the Moon annually, with no protective atmosphere to burn them up. This dust, once a challenge, becomes building material. The regolith's composition is remarkable. 45% silicon dioxide, 15% aluminum oxide, 12% iron oxide, 11% calcium oxide, 9% magnesium oxide. Essentially, the Moon is built from the same elements we use for concrete, glass, and metal on Earth. Future construction teams could manufacture building materials from the very ground beneath them. Shipping costs from Earth eliminated. Sustainability achieved through resourcefulness. ARTEMIS, the program making this vision real, takes its name from Greek mythology. Artemis, twin sister of Apollo, goddess of the moon. NASA Administrator Jim Bridenstine announced the name in March 2019, symbolizing the next chapter after Apollo's achievements. Where Apollo planted flags and footprints for brief visits, ARTEMIS will establish homes and laboratories for permanent presence. The transition from exploration to habitation, encoded in the very name. On October 13th, 2020, the first 8 nations signed the ARTEMIS Accords. Australia, Canada, Italy, Japan, Luxembourg, the United Arab Emirates, the United Kingdom, and the United States. Now, 27 nations have joined, establishing principles for lunar governance. Peaceful purposes, transparency, interoperability, emergency assistance. These accords frame the Moon not as territory to claim, but as commons to share, a home for all humanity willing to reach it. Step forward through the airlock's inner door. The corridor ahead curves gently, following the habitat's dome structure. Soft lighting bathes the walls in warm tones, 3,000 to 3,500 Kelvin, designed for psychological comfort. Apollo astronauts lived in 6.65 cubic meters of space, cramped and functional. Future base designers allocate 125 cubic meters per person, 19 times more room, space to breathe, to think, to feel human. Above the corridor ceiling, 2 to 3 meters of regolith provide shielding. On the lunar surface, cosmic radiation levels reach 380 millisieverts per year, compared to just 2 to 3 on Earth. Without protection, prolonged exposure would be dangerous. But beneath this blanket of lunar soil, you're safe. The very material that challenged Apollo missions now serves as guardian, absorbing radiation, moderating temperature, creating sanctuary in vacuum. The Moon's atmospheric density measures 100 trillion times less than Earth's. 10 to the negative 12th atmospheres. Essentially hard vacuum, requiring complete habitat pressurization. Yet this vacuum, hostile to life, offers unexpected advantages. Manufacturing processes impossible on Earth thrive here. Vacuum metallurgy, perfect crystal growth, ultra-pure materials production. The lunar environment, properly harnessed, becomes not just survivable, but valuable. A unique laboratory floating in space. Notice the silence. Perfect, absolute silence. Sound requires atmosphere to propagate, and the Moon has virtually none. Outside these walls, you could stand beside a massive mining operation and hear nothing, see only the machinery moving in eerie quiet. Inside, designers include subtle ambient sounds, soft air circulation, gentle mechanical hums, audio textures that prevent the psychological discomfort of total silence. Humans need some sound to feel at home. You pass a window set into the corridor wall. Through it, Earth hangs in the black sky, brilliant blue and white, approximately 2 degrees of arc across, 4 times larger than the Moon appears from Earth. It provides 13 times more light than a full moon. Astronaut Buzz Aldrin called the lunar landscape magnificent desolation. But with Earth visible, you're never truly alone. Home watches over you, a constant companion in the void. The base location near Shackleton Crater was chosen with precision. The lunar South Pole features peaks of eternal light, mountains that receive sunlight 70 to 90% of the year, solar arrays positioned there could generate nearly continuous power, eliminating the need for massive battery storage during the long lunar night. Meanwhile, the permanently shadowed crater depths remain at -240 degrees Celsius, among the coldest places in the solar system, preserving water ice for eons. Engineers reference Gateway, the lunar orbit station approved in 2019. It follows a near rectilinear halo orbit, an elliptical path between 3,000 and 70,000 kilometers above the Moon. Gateway serves as a staging point for surface missions, communications relay, and refuge. From this base, you could look up and occasionally spot Gateway passing overhead, a bright star in steady motion. Humanity's outpost supporting humanity's outpost in an expanding network of presence. European Space Agency Director General Johann Dietrich Werner proposed the Moon Village concept in 2015, an international lunar settlement, successor to the International Space Station, where agencies and even private companies work side by side. In June 2021, China and Russia announced plans for an international lunar research station at the South Pole by 2036. Multiple visions, converging location. Perhaps someday these separate dreams will merge into one shared home. Let's move deeper into the habitat. The corridor opens into the habitation module, where future lunar residents would live their daily lives. Private sleeping compartments line the walls, each with a small window, personal space, touches of home. Photos, plants, books. Humanity's need for individuality, honored even here, 384,000 kilometers from Earth. Apollo 17 astronauts Eugene Cernan and Harrison Schmitt spent 75 hours on the lunar surface in December 1972. The longest moon stay until future ARTEMIS missions. But they lived in 4.5 square meters of floor space, sleeping bags strung between equipment. These new compartments, designed for months of occupation, prioritize psychological well-being alongside survival. Wally Schirra said in 1969, "We went to the moon with flags and footprints. Our children will go with homes and laboratories." His vision materializes around you. Common areas where crews share meals, collaborative workspaces, observation lounges for contemplation. This is architecture for living, not just surviving, for thriving in alien gravity. The moon's escape velocity measures 2.38 kilometers per second, compared to 11.2 from Earth. Launching into space from here requires only 21% of the energy. The base becomes a staging area for deeper solar system exploration. Fuel manufactured from lunar water ice could propel missions to Mars, asteroids, beyond. The moon as gateway, literally and figuratively. Walk toward the greenhouse section, visible through transparent partitions ahead. Green leaves contrast beautifully against grey walls. Living plants serve multiple purposes: oxygen production through photosynthesis, carbon dioxide absorption, food supplementation, and perhaps most importantly, psychological comfort. The human spirit needs green growing things, needs to nurture life, especially in environments defined by vacuum and stone. Tiered growing racks rise from floor to ceiling under specialized LED arrays. Engineers calculate closed-loop life support systems that recycle 95% of water and oxygen. Waste becomes resource. Every breath you exhale feeds the plants. Every drop of water the plants transpire returns to you. A balanced ecosystem in miniature, contained within pressurized walls. The lunar soil contains 40 to 50 parts per million of hydrogen, deposited by solar wind over billions of years. With appropriate technology, this hydrogen could be extracted and combined with oxygen from regolith processing to create water. Even the dust holds resources. Nothing wasted. Everything utilized with careful ingenuity. Konstantin Tsiolkovsky wrote in 1903 about lunar colonies with greenhouse domes, using lunar minerals for glass. Over a century later, his vision approaches reality. You stand in a space he imagined before powered flight existed on Earth. Human imagination, given enough time and determination, transforms into engineering blueprints, then physical structures. Beyond the greenhouse, the ISRU facility processes regolith samples. ISRU, in situ resource utilization. The philosophy of using what's available rather than shipping everything from Earth. Machinery quietly extracts water molecules from ice-bearing soil. Electrolysis splits water into hydrogen and oxygen. Breathable air and rocket fuel from frozen lunar dirt. The permanently shadowed regions of Shackleton hold their water ice precisely because sunlight never reaches them. Temperatures never rise above -200 degrees. For billions of years, these deposits accumulated from comet impacts and solar wind interactions. Now humanity plans to harvest this ancient resource carefully, sustainably, making the moon habitable. NASA Administrator Bill Nelson said in 2021, "Artemis is not just about going back to the moon. It's about staying, living, learning, and preparing for Mars. The base around you serves as proving ground. Technologies tested here, life support refined here, psychological protocols developed here, all transfer to the longer, more isolated journey awaiting humanity on the red planet." The scientific laboratory occupies the next module. Through the window you see researchers in casual clothes, not bulky spacesuits, examining samples under microscopes. The vacuum environment and low gravity enable experiments impossible on Earth. Crystal structures grow larger, purer. Biological processes reveal themselves differently under 0.166 G, offering insights into life's adaptability. Lunar regolith's bearing strength measures 50 to 100 kilopascals when compacted, sufficient to support multi-story habitats with proper foundation distribution in low gravity. Engineers design with confidence, knowing the ground beneath can hold structures, equipment, greenhouses. The moon's surface, stable for construction, unchanging for eons, becomes humanity's second foundation. Helium-3 exists in lunar regolith at concentrations reaching 1.1 million metric tons total. This isotope, rare on Earth, is potential fuel for future fusion reactors, offering 10 times the energy efficiency of deuterium-tritium reactions. The moon doesn't just support human presence. It may someday power civilization across the solar system, an energy reservoir waiting in the dust. Approximately 3,000 shallow moonquakes occur annually, magnitudes 2 to 5 on the Richter scale. Apollo seismometers detected them during missions decades ago. Habitat designs account for this seismic activity, with flexible connections between modules, dampening systems, structural redundancy. Even on the moon, the ground occasionally trembles, a reminder that worlds are dynamic. You move past storage areas holding supplies launched from Earth and materials processed locally. The balance shifts over time. more lunar, less terrestrial. Self-sufficiency grows gradually. First missions bring everything. Later missions bring only what the moon cannot provide. Eventually, perhaps, the base sustains itself almost entirely. NASA's first lunar outpost study from 1992 detailed plans for a 4-person base using in-situ resource utilization. Over 30 years later, the concepts mature, refine, approach implementation. Patience defines space exploration. Decades pass between vision and reality, but the vision, once articulated, persists, guides, eventually manifests when technology and will align. Samantha Cristoforetti, ESA astronaut, observed that the moon doesn't belong to any nation. A lunar base must be international, peaceful, and open. Her words echo the Outer Space Treaty principles. This habitat could house astronauts speaking Mandarin, Russian, English, Japanese, Arabic, French. Cooperation made tangible in shared meals, joint research, mutual survival. The solar constant at the lunar surface measures 1,368 watts per square meter during the lunar day. Abundant energy when the sun shines. Solar arrays unfold across regolith plains, tracking the sun's slow arc across the sky. Power flows into batteries, systems, life support, lights. Sunlight becomes survival. Travel time from the lunar surface to Earth requires 3 days with current chemical propulsion technology. Apollo's spacecraft covered 384,400 kilometers in approximately 76 hours. Emergency evacuation, theoretically possible, but in practice, lunar base residents accept the isolation, the distance, the commitment to remain for weeks or months before rotating home. Wernher von Braun proposed a lunar base in 1969, envisioning underground facilities at Marius Hill's lava tubes, with rotating 50-person crews by the 1980s. His timeline proved optimistic, but his core insight remains. Lava tubes offer natural radiation shielding, stable temperatures, ready-made volume for expansion. Nature provides, if we look carefully. Lunar lava tubes measure up to 5 kilometers wide and hundreds of kilometers long. Enormous empty spaces formed when molten rock drained away billions of years ago. Imagine habitats built inside these natural cathedrals, protected by solid rock overhead, entire settlements hidden beneath the surface. The moon honeycombed with potential homes. The base you're touring could be surface domes like this, or subsurface warrens in lava tubes, or hybrid designs combining both. Architectural studies explore every option. Perhaps the first base establishes itself in a crater near water ice. The second, inside a lava tube for radiation protection. The third, at a peak of eternal light for solar power. Multiple communities, diverse solutions. The lunar horizon, from an observer 1.7 meters tall, sits just 2.4 kilometers away. Earth's horizon extends 4.7 kilometers under similar conditions. On the moon, the world feels smaller, more enclosed. The curve of surface drops away quickly. Psychologists study how this claustrophobic visual effect influences long-duration cruise. NASA's Commercial Lunar Payload Services program awarded $2.6 billion to 14 companies between 2019 and 2024. Robotic landers deliver cargo, test technologies, prepare infrastructure. Before humans arrive to stay, machines pave the way, positioning supplies, validating systems, reducing risk. Robots and humans, partners in settlement. Christina Cook, current ARTEMIS astronaut candidate, said the moon is our training ground for Mars, our testing ground for technologies that will take us farther into the solar system. Every lesson learned here, every system perfected here, every challenge overcome here, translates to knowledge for harder journeys. The moon teaches humanity how to live beyond Earth. You notice the gentle pull of lunar gravity, 1/6 Earth's strength. Objects fall slowly. Movements feel effortless, almost floating. Over weeks or months, muscles adapt, bones adjust, cardiovascular systems recalibrate. Medical teams monitor residents carefully, developing countermeasures, understanding how human physiology reshapes itself in alien gravity. The moon has no global magnetic field, less than 0.0001% of Earth's strength. No magnetosphere deflects solar wind or cosmic radiation. Protection comes only from mass. Regolith overhead, water tanks positioned strategically, underground shelters for solar storm events. Designers think in layers, redundancy, shielding mass. Gerard O'Neill proposed lunar mass drivers in 1977, electromagnetic catapults to launch materials to space stations, minimizing Earth launch costs. The concept endures in current planning. The Moon's low gravity and lack of atmosphere make it ideal launching point. What we build here could supply construction projects throughout cislunar space, resource depot for orbital industry. Apollo 15 astronauts David Scott and James Irwin drove 27.9 kilometers in their lunar rover during July 1971. Future pressurized rovers designed for 500-plus kilometer range with 14-day endurance. Imagine week-long expeditions across lunar Maria, exploring distant craters, collecting samples, experiencing the Moon's vastness with protection and comfort. Charlie Duke, Apollo 16 astronaut, reflected, "I'd love to go back, not for a few days, but to live there. Watch Earthrise every day and see what we can build together." His dream materializes around you, a place to live, to work, to build, to look up at Earth and know you're part of something larger. You approach the observation dome, the heart of the base's contemplative spaces. Transparent panels curve overhead, providing unobstructed views of the lunar landscape and the sky beyond. This is where off-duty crews come to think, to rest, to remember why they're here. Beauty justifies hardship. Wonder sustains commitment when Earth feels impossibly distant. Step inside the dome and settle into a comfortable viewing chair. The seat adjusts to lunar gravity, supporting you gently, allowing you to recline and gaze upward. Silence surrounds you. Not the silence of isolation, but the silence of peace, of contemplation, of connection to something vast and ancient. Look up. Earth hangs in the black sky, 2 degrees across, 4 times the Moon's size as seen from home. Brilliant blue oceans, white cloud swirls, brown continents. Everything you've ever known, everyone you've ever loved, contained in that delicate sphere. From the near side of the Moon, Earth never rises or sets. It remains stationary, shifting only slightly with libration oscillations over 27.3 days. A constant companion, always there, always watching. Home in the sky. The overview effect, astronauts call it. Seeing Earth from space fundamentally changes perspective. Borders disappear. Conflicts seem trivial. The planet's fragility becomes obvious, its beauty overwhelming. Living here, experiencing this view daily, would that effect deepen, transform how we see ourselves? Harrison Schmitt, Apollo 17 geologist, said, "The moon is the Rosetta Stone of the solar system. Living there, we'll understand not just the moon, but Earth and our future. Knowledge gained through presence, through patient observation, through calling this place home." The stars around Earth shine without twinkling, no atmosphere to distort their light. Sharp, steady points against absolute black. Constellations familiar yet transformed, clearer than ever seen from Earth's surface. The universe reveals itself with perfect clarity. Eugene Cernan's final words leaving the moon in December 1972. "We leave as we came, and, God willing, as we shall return, with peace and hope for all mankind." His hope materializes in this habitat, in these plans, in humanity's determination to return, this time to stay. Notice the stillness outside. No wind, no weather. Dust disturbed by a rover remains in footprints for millions of years until the next micrometeorite impact. The moon preserves everything, patient, unchanging, holding human history in its regolith-like memory. The black of space feels deeper here, more absolute. On Earth, even at night, atmosphere scatters light, creating glow. Here, black means total absence, infinite depth. Looking into it, you look into forever. A small reddish point shines beyond Earth in the darkness. Mars. The next destination, the next base to design, the next home to build. This lunar settlement, if it succeeds, becomes template, practice, foundation for longer journeys. Rest here in the viewing chair. Let your breathing slow, matching the patient rhythm of this place. No urgency exists on the moon. Time moves differently when days last a month. You notice how quiet your heartbeat sounds in this stillness. The gentle pulse of life in vacuum's embrace. You are alive here, warm, breathing, thinking, feeling, protected by human ingenuity. The dome's transparency makes you feel exposed to space, yet completely safe. Paradox of modern materials. Invisible barriers between you and instant death. So clear, you forget they exist. Earth rotates slowly from this perspective, continents drifting across the visible hemisphere. India, Africa, the Pacific. Day and night boundaries curve across the surface, terminator line always moving. Sally Ride wrote in 1987, "A lunar outpost would demonstrate our ability to live and work productively on another world. This demonstration unfolds around you, quiet proof of human adaptability." Moonquakes rumble occasionally beneath the surface, small tremors in ancient rock. The moon's interior still cools, still settles. Even geologically quiet worlds retain faint echoes of formation. Imagine living here for a month, watching Earth's continents rotate through view, seeing weather patterns develop and dissolve, perspective expanding with each day, connection to home both strengthened and transformed. The base community would develop its own culture over time. Traditions, humor, ways of speaking. Humanity adapts everywhere, creates home wherever protection and purpose exist together. Resources below: water ice, helium-3, building materials. Resources above: solar energy, vacuum for manufacturing, low gravity for launching. The moon offers everything needed if humanity brings knowledge to unlock it. James Irwin, Apollo 15 astronaut, felt spiritual presence on the moon. The profound silence, the stark beauty, the sense of creation, sacred not through construction, but through essence, through being. You feel yourself relaxing deeper into the chair, muscles releasing tension they've held. Lunar gravity gently supports you, 1/6 Earth's weight. Floating sensation, almost dreamlike, completely peaceful. The temperature inside remains constant, perfect comfort despite 300-degree swings outside. Technology creating oasis, human needs met through layers of systems working silently, invisibly. Beyond the dome, the regolith plain stretches toward close horizon, 2.4 kilometers distant. Grey, textured, ancient. 4 billion years of history beneath each footstep. Geological record preserved perfectly. You imagine future children born here. First lunar generation. What would Earth mean to them? Home they've never touched. Blue world in black sky. Story parents tell. The moon holds no life except what humans bring. Plants in greenhouses, bacteria in recycling systems, people in habitats. Life establishing foothold on lifeless world. Biology expanding into geology's domain. International cooperation makes this possible. No single nation could sustain a lunar base alone. Shared dreams, shared costs, shared glory, shared home among the stars. You hear soft footsteps in the corridor behind the dome. Another base resident arriving to watch Earth. Companionship in contemplation. Shared wonder at the view that never becomes ordinary. It's time to rest now. Let's walk to the sleeping quarters. Slowly, peacefully. Your body feels light, relaxed. The corridor curves gently ahead. Warm lighting guides you. Each step effortless in low gravity. You pass crew members preparing for sleep shift. Quiet greetings exchanged. Community settling into night's rhythm. Your sleeping compartment waits at the end of the hall, a private space designed for rest, your sanctuary. The door slides open silently. Soft amber light illuminates the small room. Welcoming, peaceful, yours. A sleeping restraint system anchors to the wall, adapted for lunar gravity. Gentle support, floating comfort. The window beside your sleeping area frames Earth perfectly. Constant view. Home always visible. You settle into the restraints, feeling their gentle embrace. Secure, safe, held. The compartment's walls are covered in soft acoustic panels, absorbing sound, creating intimate quiet. Lighting dims automatically to sleep levels. Warm darkness, perfect for closing eyes. Through the window, Earth's terminator line divides day from night. Eternal rotation, time's passage. You notice how easily you breathe here. Oxygen recycled from greenhouse plants. Life supporting life. The habitat hums very softly around you. Life support working. Systems protecting, nurturing. Your muscles fully release their tension now. Lunar gravity's gentle pull, almost weightless. The moon beneath you has existed for 4 billion years. Ancient foundation, supporting your dreams. 600 million tons of water ice wait below. Future secured. Humanity's next chapter. Your eyes grow heavy watching Earth's blue glow. So beautiful, so far. The peaks of eternal light shine somewhere above. Constant sunlight, endless possibility. This base exists in tomorrow's plans today. Dreamers envisioning, engineers calculating. Someday, someone will sleep here truly, making this real, living the dream. Rest now, peaceful, safe in tomorrow's home. Hygiene. Earth watches. Blue jewel, constant companion. Breathing slows, heartbeat quiets, drifting, love. Lunar gravity cradles, gentle, floating into sleep. Stars beyond, infinite black, perfect peace. I've loosed intertext for there would be startant to be sard. Base surrounds, protection, shelter. Future becomes present, dreams solid, hope manifest. moon beneath, earth above, you between. Silence complete, peaceful, whole. Water, ice, waiting, resources, sleeping, tomorrow's promise. Regolith shielding, protecting always. Guardian moon. Weightless rest, floating dreams, peaceful. Window shows home. Blue world, always there. eyes closing, breath soft, sleep arriving. Tomorrow's space, tonight's dream, rest. Moon holds you. Space surrounds. Peace complete. Drifting now, safe, dreaming tomorrow. Sleep among stars, home